My name is Derricke, and my title is the Product Manager of Bentley Civil Americas. And basically what that means is I'm over both the En-ROADS and Geopack product lines for both North and South America. And today I'm going to just take a few minutes to talk to you a little bit about the ROI of 3D modeling. Now, as many of you may or may not know, there are two fairly significant engineering software solutions and rollouts that's in the process of happening in TxDOT. One of those is the engineering content management, which is ProjectWise, which one of my colleagues will be talking about in another session. But what I want to do today is I want to focus on 3D modeling. And specifically tomorrow morning I've actually got a presentation where I'll do a demonstration of 3D modeling and show you how the software works and that kind of thing. But today in particular I want to talk about the return on investment of 3D modeling. Now there was, before I get to that, I want to kind of take a quick look back. I've been involved in engineering and CAD since 1986, so a long time. And there's one thing I've noticed over the years, and that is the fact, if you really think about it, in the last 25 or 30 years, our technology has just progressed dramatically. I mean, we've gone from Mylars to 3D online PDFs. We've gone from drafting tables to iPads. We can actually put 3D models on iPads in the field. So our technology has just made incredible advances. But when you step back and look at it, what's happened is that other things have not advanced. For example, our business practices, our workflows, and specifically our deliverables have continued to target the same things that they did 25 years ago, and that's 2D plans production. We may have gone from Mylars to PDFs, but we're still doing 2D plans. We may have gone from drafting tables to iPads, but we're still doing 2D plans. Now, we've been doing 3D models for a long time. I picked this little animation not because it's the coolest one I've got. I've really got a lot of really neat and cool animations. I actually picked this one because it's the oldest one I have. This is the Hoover Dam bypass. And you can see it's a split level animation up top. You've got the kind of the virgin territory down below. You saw the structure there. You're seeing the roadway. This was actually done for like stakeholder buy-in to go before the Environmental Protection Agency, to go before other stakeholders and get buy-in. But we've been doing those type of models for a long time. Again, I just use that because it's the oldest one that I have. And in fact, since 2006, in the last 8 years, we've had software applications that we've built who specifically were designed to build 3D models, and we call it Roadway Designer. What we found, though, is that even in agencies that are doing 3D models, they're still shoehorning 3D models into 2D workflows. I was out at a DOT about 5 weeks ago. They're actually building 3D models, and all their projects are done with 3D models. But when it comes time to run earthwork, they take that 3D model, they cut cross-sections out of it, and they run average end-area earthworks, which makes no sense when you think about it. You got a model that's sitting there that'll give you the most accurate cut and fill values that you can possibly get, but yet we cut cross sections and run average end-area earthworks because that's just the way we've always done it. Even though we've got a model, our primary means of exchanging data is still plan sets. Instead of passing the digital data along, we tend to pass plans along, for example, from design to construction, or maybe say from design over to hydrology. There was a study done by Oregon State University about 3 or 4 years ago, and they surveyed the DOTs, and they asked this question: what are the factors that are holding back the implementation or the adoption of 3D workflows in your agency? And there's a lot of factors. Some people just said, look, it's technical expertise. We don't know how to do it. There's things like inertia. We all know what that's like, right? We've done it the same way for a long time. I've always met my letting deadlines. Why would I change if it's not broke? Why would I even try to fix it? One of the things that really popped out at me, though, was this one when I read this study, is that basically a quarter of the respondents said that when it comes to 3D modeling, I just don't see any value in it. And that really kind of jumped out at us as a software company, is that we understood people are not seeing the value behind 3D modeling. So this was kind of the impetus for this presentation that I've kind of gone around the country and done for many DOTs, and was able to do for the TxDOT executives several weeks ago. And so I'm going to, there's actually, this presentation in its fullest can run me about an hour. There's actually about 9 or 10 valid business drivers that we can talk about. I'm going to strip it down here because I only got a little bit of time, and I'm going to talk about four business drivers, 4 things that give you a real return on investment with 3D modeling. And the first one of these is what we call design review. There is no doubt, and I don't think anybody in this room would argue this point, that the ability to use a 3D model in design, the ability to have a picture there in front of you where you can see how things fit together, is just a huge return on investment. In other words, if I can look out there, whether it's a side slope mismatch, whether it's a structure where somebody maybe inadvertently entered the wrong value into a tabulation table and passed that over to me and it got typed in wrong, or whether it's utilities that clash with my storm sewer design or my storm water design, having the ability to model those things and visually see them as an engineer or as a designer allows me to find those flaws and omissions early in the design process and not wait until they get caught by the contractor when this facility is being built. And so what we want to do is we want to take visualization, we want to take these 3D models, and we want to put them in the hands of an engineer, of the designer, as early in the process as we can. Now, to do that, we knew we had to make some significant changes. First of all, we had to make it easy. We can't have a situation where a designer designs something and then sends it across the room to the other side of the building to a group whose job is to visualize, and then they work on it for a week and send it back, and then we realize, oh, this is not going to work. It has to be immediate feedback for the engineer. The other thing we wanted to do is we did not want to make people work in 3D. A lot of people are very, I won't say fearful of 3D, but most of our CAD technicians and engineers are very familiar with 2D. We understand 2D. When you get into a 3D, that can be a little bit intimidating. So we wanted the results to be immediate, and we wanted the user to be able to work in 2D and get 3D for free. And so we come up with something called design time visualization. And they say a picture's worth 1,000 words. So let me show you this. This is our Bentley Civil software. On the left here, I've got a 2D view. On the right, I'm in 3D. What I'm doing is I'm selecting this alignment. I'm going to apply a typical section along this alignment. I'm putting in my beginning and ending station. And what it does, as soon as it applies that typical, I get an immediate 3D feedback visualized in my road. Now notice again, I'm working over here in 2D. I actually want to widen my outside lanes here. So I'm coming over here. I'm putting in the beginning and ending stations of where I want my widening to start and stop. Notice I'm identifying the edge of pavement or the alignment that I want to use for my widening. As soon as I apply that, the model's going to reprocess and you get immediate 3D visual feedback. I want to come in here and let's say, for example, on this project, and this is an actual project from Missouri DOT, I've got a railroad overpass bridge, so I'm going to reference in this railroad bridge both into 2D, but I'm also going to reference there into 3D, so I can visually see what's going on. I widen this outside lane, so now I've got this barrier wall that also needs to be widened to protect this pier. So again, I'm over here in 2D. I'm selecting my project here. I'm going to do what's called a parametric constraint. I'm telling it I want to widen my wall, where I want to start the widening, where I want to end the widening, and you'll notice it automatically updates the model, and I can visually see, is what I'm designing, is that going to work? Is that going to protect that? Same thing here. You'll notice when I originally applied my corridors through this area, I had these big cut slopes in here. Obviously, I'm going to do something a little different in the area of the bridge. So what I'm going to do is I'm going to go to a cross-section view. This is the area I want to replace. I'm going to come over and drag in a retaining wall to the back of the shoulder. In this cross-section view, I'm going to say OK. As soon as I do, the model's going to update and you're going to see the wall replace the slopes in that area. One more example here. I want to put in some guardrail in this area. Notice I'm going to go into 2D. I'm going to put in a variable offset taper representing my guardrail. That has a feature called guardrail, so the software knows what it is. I'm going to say add that to my model. As soon as I do, the guardrail is going to be automatically visualized in 3D. So I'm getting immediate visual feedback. It's called design time visualization. Working in 2D, but getting 3D for free. Now, this is true no matter what part of the product you're in. For example, here I'm doing some drainage. Same thing's true. Over here I'm in 2D. Here I'm in 3D. I'm going to come into my properties here for my inlet here, and I'm going to change this to I think to a head wall, a flared in section. So I'm going to change it to a flared in section in 2D. Notice in 2D it updates, but it also updates in 3D. So we're going to model these structures for you. We're going to model them just as accurate as we can, because remember, at the end of the day, we want to get accurate quantities from this model. We want to run clash detection against this model. So the more accurate it can be modeled, the better. And so the software will do that for you. I've got another example here of an inlet, and this is what most softwares will do today. They'll kind of create these little boxes to represent your inlets. I want to show you a little bit of what this can do. I'm going to come over here in 2D, and I'm going to select the properties for this inlet, and I'm going to change it to a different type of inlet. And so I'll just select this type X here. You'll notice it changes it in 2D and also in 3D. If you want to rotate the inlet, you just pick it up in 2D, you rotate it around. Okay, make the rotation. As soon as you do, you'll notice 3D updates, and it's all rotated for you. If I zoom in, you can see the level of detail that we can build into these structures. Notice here I'm just using MicroStation. I can change views from like transparent views. You can notice here the pipe, now that I've rotated the structure, the pipe doesn't line up. If I want to move it, I just pick it up and move it in 2D. It automatically moves in 3D. And so what you're doing here is this is called design time visualization. As an engineer or designer, I can design in 2D, but I'm getting that 3D immediate feedback for free. What we're doing with this is we're making 3D. We're making visualization more than just a pretty picture. We're putting it in the hands of the designer as early in the process as possible. The goal is to find those errors and omissions early in the process, improve our decision making, improve coordination between disciplines. At the end of the day, we get higher quality and produce a better design. The second one, a driver that's a return on investment that we get with 3D modeling is asset management. Today what we're doing is we're producing 2D plans. Maybe we produce some grading models that go out to our contractors, but we really don't have anything to feed downstream into operations and maintenance. But once we have 3D models, we've got something that can live throughout the life cycle of our project. So we can take our model, we can feed it into things like drainage pipe and culvert inventories. We can feed it all of our utilities and stormwater systems. We can feed that into GIS. We can do things like vertical clearances for permitting and truck routing. Here's an example of this. Here's a job that we've gone out and we've shot it all with LiDAR. And so LiDAR is an integral part of this. I've got an oversized vehicle that I've gone into the software, and I've actually created a shape here that represents that oversized vehicle. Now I'm going to run a clash detection. And so I'm going to say I want you to check this oversized vehicle against the point cloud. And so what we'll do here is once we say the point cloud against that, we'll do a quick process. It'll go along this baseline, the alignment that we want to move that vehicle along. It'll find all of my clashes. So you can see here it's telling me you're going to clash with an overhead sign if you send that vehicle along that way. And then you can see right here it clashed with an overpass. And so we feed that model downstream, and then later on, like I said, if we've got permitting and vehicle routing systems, we can use that later on as well. The third one that I want to point out this afternoon, of course, is machine control. This is one that's been around for probably the longest, and is probably one of the most well-known return on investments when it comes to 3D modeling. This is this is just a functionality and that just continues to grow within the industry. If you're ever interested, you can go out. There's an online magazine called SitePrepMag.com, which is basically an online magazine for contractors, and they do This was their 7th year. They do a machine control report, and where they survey the contractors, how much machine control are they using, how much are they planning to buy in the coming months, and you just see the use of this software, the use of this functionality in the industry just continues to grow when it comes to automated machine guidance. And the reason for this is the productivity gains. There's been several reports done on this. You'll see productivity gains return sometimes as high as 40%. What contractors will tell us is they're doing less repeat work. They're moving dirt right the first time. Because of that, lower fuel consumption, a reduced fuel consumption, lower cost. It's accurate. You get a better ride, and it's safer. You're not putting up all the stakes and strings that that get washed out, and you have to re-put them up again. Again, it's all digital. And it's just resulting in safety on the thing. One of the really interesting things about machine control is this. I was in 2010, I was at the AASHTO Right-of-Way and Utilities Conference in St. Louis, and I was talking to a gentleman from a company called Underground Imaging Technologies, and they are a company that they use ground penetrating radar. They're the guys on the side of the road that's got the little things, and they're going along and finding our utilities and marking them for us. And he mentioned to me in that conversation that their company had just been bought out. And when I asked him who bought them, he said Caterpillar. And I thought, well, now that's odd. Why would Caterpillar, who makes all this machine control equipment and all this, why would they be interested in buying a company that uses ground penetrating radar? But then when you delved into it a little bit more, what you found out, it made perfect sense. You see, today, when that machine control operator, he or she, they get on that grader, all they see on their little panel is they see the dirt. But what Caterpillar wants them to see is what's under the dirt. And so they want that grader, that grader operator, as they're driving, they want them to know that, hey, 300 yards up there, you got a 6-inch gas main. Or a quarter mile behind you, you got a high voltage overhead electric. So this is a functionality that just continues to grow. So eventually, when you get on a grader, when you get on a paver, you get on a machine control excavator, you'll not only see dirt and elevations, but you'll see what's below the dirt and what's above the dirt as well. Now, one thing we've been able to do for years and years is provide artifacts of design to construction. For example, we can send out geometry through proprietary files like Leica and TopCon and Trimble or ASCII. We can take geometry and triangulated surface out through LandXML files and feed those into the contractor. One of the things you'll find out when you talk to contractors is when we do a project, they want 3D line strings. Give me the 3D break lines for the edge of pavements, the back of curbs, the bottom of ditches, the tops of berms. We can do that. We can export those out through DGN, DWG, or DXF, and we've been able to do that for many, many years. But you'll notice one of the things about this is we're kind of taking out pieces of the project. We're taking out geometry, we're taking out some surfaces, we're taking out some 3D break lines, but we're not doing the whole model. And the other thing that's missing from this is all the engineering content. For example, I can take a pipe and I can send the invert of that pipe out as a 3D line string, but I can't send him the engineering content. I can't give him, for example, what's the hydraulic flow, what's the slope of the pipe, what's the upstream node, the downstream node, what Manning's coefficient was it designed with. And so we've been working for a while to say, how do we move the model downstream to the contractor? And so I want to show you this. This is something we just implemented back in July. This is a project here inside of Bentley Civil, and you'll notice here this all reference files. So I've got two corridors. I've got a northbound and a southbound. They're all in reference files. The northbound geometry is in a file, the corridors in a file, the drainage is in a file, the bridges are in a different file. I'm going to come in here and create what's called an ICM. This stands for a consensus model. I'll just hit that icon. It says, do you want to include the design models and the terrain models? I'm going to say OK. So again, what it's going to do is it's going to take all that federated data from my project, doesn't matter how many files it is, and it's going to create a single model called a consensus model. Now, once that's done, what I'm going to do here is I'm going to exit out of the Bentley Civil, and you can see I've created this file here called i95.icm. It created a single file. Now what I'm going to do is I'm going to open Trimble Business Center. So this is Trimble Business Center HCE, the Heavy Civil Edition. This is what a contractor would be running. So a contractor out in the field now can come in here. I'm going to create a new project here. Just say OK, and you can see it's blank. I'm going to go up to import, and I'm actually going to take that Bentley Civil model that was designed by the agency or the engineering firm. A couple things here on the bottom. You'll just say what data do you want to import. I'm going to say all. And a couple other settings, I'm going to say import. And so what Trimble Business Center is going to do, it's going to import all my alignments, it's going to import my corridors, it's going to import my surfaces, my existing ground, all of that. You can see here it's actually drawing it now inside of Trimble Business Center. And once it draws it, boom, you'll see it come up. And there's our project that we did inside of Trimble Business Center. And so, again, the contractor has access now. For example, if he wants to look at it in 3D view, he can come over to this is a fully 3D. So I'm just going to change the vertical and horizontal here inside of Trimble Business Center so you can see it's fully 3D. If they want to look at the profiles that I delivered with the project, I can come over here to a corridor tab. And we'll just come over here and open up a profile view. And so they have access to all of my profiles. They can take that out to machine control, do whatever they need to do with it. If they want to look at cross sections, they can change to a cross section view. They can look at the cross sections inside of Trimble Business Center anywhere from my project here that I sent to them. And then finally, if they want to run some earthwork, they've got access. If I come over here under the properties, notice they've got access to all the northbound corridors. They can go look at the properties here. They can change the original ground setting the properties here. If they want to run earthwork in their product, they can. So we'll just say I want it reported on every 25 feet. Say OK. And it's going to run the earthwork. So we've taken a Bentley Civil model that we designed, taken it completely over to Trimble Business Center where that contractor can do what they need to do with that. The last one that we'll look at here is what we'll call public involvement visualization. A huge return on 3D modeling. Really, what makes this such a big deal is I always point this out. Everybody says, what's the big deal behind visualizations? Well, what visualizations do is they convert complex technical information into easily understood images or animations. I remember the day where you'd go to a school cafeteria, you'd put up easels around the room, you'd put your 2D plans up, and you'd spend the next 2 hours trying to explain to some business owner what that is. They have no clue what's on those plans. You show them a picture like this, a picture's worth 1,000 words. This is your existing intersection. This is what it's going to look like after the roundabout is done. So it eliminates that need to interpret 2D drawings. It allows us to communicate that single common vision. If you're doing these local government projects that may be politically sensitive, it allows us to coordinate. It allows us to get that stakeholder buy-in. And you can see with design time visualization now, as you're designing, you're building the visualization, you're getting this 3D visualization for free. So taking it to a final product, putting the cars on it, doing the animations, much, much simpler than it used to be. So what we've tried to do here is kind of make a business case for 3D modeling, and there's really 3 areas. Number one is time saving. If we can see everything, how everything fits together up front, leading us to better decision making in the process. We're going to eliminate a lot of that work on the back end, eliminate those change orders. Visualization is great for allowing us to assess and evaluate those design alternatives. Secondly is cost savings. Again, fewer change orders, fewer field modifications is going to lead to significant cost savings on our project. And then finally, quality. One of the things that we really do today is whether it's hydraulics, in design or construction as design, we tend to work in these federated workflows where we're kind of separate. We don't ever really bring everything together. One of the things now with visualization and design time visualization allows us to collaborate, allows to bring everybody into the model, the construction, structures and hydraulics and right-of-way and maintenance of traffic. We all can see the model. We can all visualize things. Will it work? Will it not work? At the end of the day, we can catch those errors, catch those things that would normally result from those disparate workflows and enable us to produce a higher quality project.